Hello, and welcome to Chapter 10 Homework Problem Review. Today we'll be going through problems 10-7, 10, 11, and 21. Starting with problem 10-7, we're given two projects to choose from, Project A and Project B. Both will require an upfront expenditure of $15 million. Given to us are the cash flows for each project for years 1 through 3. Part A. What are the two projects' net present value assuming the cost of capital is 5, 10, and 15%? You could see here that I've put in a cost of capital row of 5, 10, and 15% in order to calculate the net present value projects A and B. In addition to the cash flow information, we need to understand the initial cash flow of $15 million. That'll be a negative $15 million because it is a cash outflow. It's a cost of the project. So we would use our NPV formula. The rate would be 5% for the cost of capital is 5%. The values are going to be the positive cash flows for years 1 through 3. This will give us the net present value of the cash flows in the future. However, we also need to add in the initial cash flow, which is the present value equals 15 million at time 0. So our cost of our project A net present value at 5% is 16.1 million. Let's look at NPV at 10%. It's the same process. 10% is the rate. We're doing project A cash flows and we're adding in our initial cash flow in year 0, 12.8 million, and at 15%, oops, spelled NPV wrong, it's 10.1 million. Now let's do it for project B. Net present value at 5%, for cash flows, project B, plus our initial cash outflow at time 0. At 10%, project B cash flows, plus our time 0 cash flow, and then at 15%, plus our initial cash flow at time 0. So looking at the two projects, we can see that project B has a higher cash net present value in each of the situations at 5%, 10%, and 15% cost of capital. What are the two projects' IRRs at the same cost of capital? We would use the IRR formula, and we're going to actually put in our initial cash flow here. So we might miss 15 million for both projects. And then we would use our IRR formula for project A. Is 43.97%. Now you'll see that the cost of capital is not used in the IRR formula. Therefore, the IRR will be the same regardless of the cost of capital. And then let's look at project B. IRR, all of the cash flows including time 0, is 82.03. Excuse me. So given this, our project B has a higher IRR than our project A. Let's look at problem 10-10. Again, we're given two projects, project S and project L. Based on the information that was given to us in the problem, I've laid it out here. We have an initial cost of $10,000 for project X, and project L has $25,000 initial cost. And then they have cash flows for years 1 through 5, $3,000 each year for Project S, and $7,400 each year for Project L. Both of them have a cost of capital of 12%. The problem is asking us to calculate the two projects' net present values, IRRs, MIRRs, which is the modified IRR, and the profitability index. Which project would be selected assuming they are mutually exclusive using each ranking method, and then which project should actually be selected. So let's go through our analysis. First, we'll calculate the net present value at a 12% cost of capital. We're going to look at each of the cash flows and then add in the time zero cash outflow. Gives us a net present value of $814 million. These numbers are in millions. And then net present value for Project B at a 12% cost of capital. Look at years 1 through 5 and then add in time zero. This one is 1,675. Now let's look at the IRR. We're going to look at all of the cash flows here for 15.24, and then we're going to look at all of the cash flows here for 14.67. Excel has an MIRR formula that we can use, so let's look at that. MIRR. We're going to look at all of the cash flows, and then it's going to ask us for the finance rate and the reinvestment rate. That is equivalent to the cost of capital. So you're going to put in the cost of capital as the finance rate and as the reinvestment rate. In some scenarios they may be different, but that's beyond the scope of this course. So the MIRR is 13.77 for Project S, and then Project L is 13.46. The profitability index is going to take the net present value of all of the cash flows for years 1 through 5 divided by the initial cost. The initial cost here is negative, so I'm going to put in a negative here. Whoops, sorry. Because we don't want to return a negative number. Oops, I forgot the rate in the net present value formula, which is 12%. So this is going to give us a profitability index of 1.08. Looking at Project L, again, 12% is the rate. We're going to look at cash flows 1 through 5 and divide it by the initial cost. We're going to put a minus sign here so that it gives us a positive profitability index of 1067. So let's look at each of these scenarios to see which project we should choose if they're mutually exclusive. You'll remember that mutually exclusive means that we can only do one of the projects. So looking at net present value, it's going to be Project L, which has the higher net present value. Looking at the IRRs, it's going to be Project S. Looking at the MIRRs, again, it's Project S. And looking at the profitability index, it's Project S. So that's looking at the ranking system. However, the actual project that we would choose would most likely be Project L because it has a higher NPV. Therefore, it adds more value to the firm. So we should choose Project L. Let's look at problem 10-11. Your company is considering two mutually exclusive projects, X and Y, whose costs and cash flows are shown below. The projects are equally risky and their cost of capital is 12%. You must make a recommendation and you must base it on the modified IRR. Which project has the highest MIRR? Okay, so let's take a look. This is fairly straightforward. You would use the MIR formula, looking at all of the cash flows, and our finance rate and reinvestment rate, you'll remember, is the same as the cost of capital for both of those. So Project X would have a MIRR of 17.49%, and Project I would have an MIRR 18.39%. So because they're mutually exclusive, we would choose the one with the higher MIRR, which in this case would be Project Y. Let's look at Project 10-21, which deals with payback periods. Your division's considering, again, 2 investment projects. Each of them requires an upfront expenditure of $25 million. You estimate that the cost of capital is 10%, and the investments will produce the following after-tax cash flows. So what is the regular payback period for each period, for each of the projects? Okay, so let's look at this. So the first thing I did was I laid out the cash flows again, similar to up here. In order to figure out the payback period, first we need to calculate the cumulative cash flows for each year. For year 0, it's going to be equivalent to year 0. A formula that I like to use is the summation formula, and it would start with time 0 adding time 1. That would be the cumulative cash flow through year 1. However, I hard code this with $signs in front of it. This means that I can drag the formula down and it will always start with B14, which is year 0 for Project A. I'm going to go ahead and do that, copy the formula down. So you can see that it adds up years 1 through 2, years 1 through 3, and then years 1 through 4. That's just a little shortcut I like to use. We'll do the same thing for Project B. Equals sum, and then F4 for that. And then we can just copy and paste the formula down. So now that we've calculated the cumulative cash flows, what's the next step? In order to calculate the payback period, we would look at the year that it's last negative. So for Project A, it's going to be year 2. So I'm going to take year 2 plus the negative 10 divided by the year 3 cash flow that I need. So that's going to give us what portion of year 3 we complete our payback period. Okay? Oh, I'm sorry, and you have to put a negative in front of the 10 in order to get the positive calculation. So you'll see that the payback period for Project A is 2.67 years. So in order to turn from a negative cash flow, cumulative cash flow, to a positive cash flow, it happens somewhere between year 2 and year 3. You'll see that we make 15 in year 3, so we need to figure out what portion of year 3 we earn back that remaining negative 10, and it's going to be 2.67. You would do the same thing for payback for the Project B. So we look here, it turns positive in year 2, so we're going to start with 1 plus negative 5, which gives us a positive, divided by the following year cash flow. So Project B turns positive after 1.5 years. Now let's look at the discounted payback periods. So first we need to calculate that, which I've already gone ahead and done. So times 0 is going to be the present value, and then I use my present value formula, which is the cash flow divided by 1 plus the cost of capital, which you'll remember is 10%, to the first power for year 1, second power for year 2, third power for year 3, fourth power for year 4. And I gone ahead and done the same thing for Project B. And then we'll do the same thing to calculate the cumulatives. I'm going to go quickly here since we've already done it. And then I can just copy these formulas down to get my remaining cumulatives. And we're going to do the same thing. So here, it doesn't turn positive until year 4. So we're going to start with year 3 and find out what portion of year 4, so the 1 divided by the 13.66. So the discounted payback period is going to be 3.07 years for project A. And then here it turns positive in year 2. So we're going to start with year 1 and find out when that 7 is going to turn positive as a percentage of year 2. So it's going to be 1.83 years. Okay? If the two projects are independent and the cost of capital is 10%, which project or projects should the firm undertake? So in order to decide that, we're going to look at the NPV and the IRRs in order to decide which project or projects we should undertake. So net present value is going to be the year 1 through 4 cash flows. Oops, sorry, I forgot to put the rate in first, which is 10% cost of capital. And remember, you always have to add in the initial cash flow, which is already at the present value. And then we're going to do the same thing for project B. And then we're going to calculate the IRR, which is based on all of the cash flows at 27.3. All right, so let's look at what we have here. Both projects have a positive net present value, and both projects have an IRR which is greater than the cost of capital. In this case, we would undertake both projects because they are independent, not mutually exclusive. And because they both have positive net present value, we would choose both of them. Going back to the discount periods for a minute, what this tells us is that typically we have a payback period threshold. If the payback period was 2 years, we would accept project B. However, we would not accept project A because the payback period is greater than 2 years. It would take us longer than 2 years to earn back our initial investment. Here, same thing. Project B we would accept, project A we would not. Hopefully this answers some of the questions that you had on Chapter 10.